feel incredibly lucky. I work at a place where I get to test my builds by firing up a laser from an iOS device. This is incredibly exciting, but it can also be a bit frustrating. There just aren't many examples on the internet of people writing Swift for a 3D laser printer. On the backside of this frustration, though, is the fact that my work will always take me down an interesting path of learning and discovery. And today, I'd like to take you down a portion of that path that will take us through image processing and lots of transformation. The Glowforge is a 3D laser printer that you can use to make anything, like an iPhone case, or a picture frame, or a coaster. To design something for the Glowforge, you could start with a design as simple as a picture. And with this picture, you could use to make something like this. Or you could design something in a vector graphic tool like Illustrator or Sketch. Here's a design for a coaster. Ultimately, we upload an SVG file to our servers that our users can download and use to prepare their prints. And that's the coaster that you'll make from that design. If you make software for the web, there are a lot of tools that will make your job reasonably straightforward. However, for iOS, we're used to using SVG files to display our assets because they're infinitely scalable, so they will look good on any device size. Anything beyond that will require complicated, sophisticated tools, and that is what I do at Glowforge. The Glowforge will cut an outline around any unfilled shape, and it will engrave pixels in an image. This design is simply a PNG file of the Swift logo centered in an unfilled circle. One of my favorite features of the Glowforge is trace. You upload an image, and we will trace it as if you were using a pencil. I use trace to build this thing that I have on my wall. But sometimes you have something like this and you want to spice it up a bit to make it a little bit more interesting. Say, for instance, I want to cut holes within this picture so you could see through the material that you have your design on and see what's in the back. To make something like the owl, just to make it a little bit more angry. How do we do that? Say we had this picture of a cat face and we wanted to cut out the eyes. This is what it looks like inside our app. I would simply tap the area within the region I want to cut out, and you could see that we were going to draw a line that outlines the area within the region, and we would tap the region again to get the other eye outlined. So how do we do that? First thing, I find the pixels within the region, then I mark the border pixels, then I draw a Bezierpath, a line to outline those border pixels. There are many ways that you could do this, but at Glowforge, I use the flood filling algorithm that establishes that pixels have neighbors, and neighbors of the same pixels of the same color will be within that region, and any pixel of a different color will be a border pixel. So if the user was to tap this pixel in the center, it will go through and select all the white pixels around it, and until it gets to the border pixels, which would be black. So if the user was to touch that pixel on your right, it would select all the other black pixels since they are neighboring and of the same color. Then the algorithm would go through and outline this letter L to get the shape. An image can be considered as a two-dimensional array of pixels, but I am not used to working with a two-dimensional array, So I must convert this two-dimensional array of pixels to a one-dimensional array, and I do so using a buffer. But that creates a dilemma in itself, because when you tap the view, what you'll get is a two-dimensional point, and there's no way to access a one-dimensional array using a 2D point. So I fix that using simple arithmetic. If the pixel is in bounds, I find the index by multiplying the image width by the y value of the point the user selected, then adding the x value to it. And here's why this works. Say this was the image that we were dealing with, and it's a 4x4 image. We count the pixels by starting at 0 from the left, and we go to the right. So the first thing we want to do is to find the row that has our pixel of interest. So if you multiply 2 by 4, we will get the third row. And then if we add 1 to that, we will get the column. And so if the user touches a point, 1, 2, that will lead to an index of 9 inside our one-dimensional array. Say we wanted to make 6 coasters, though. The SVG graphic might look something like this. And for a single coaster within that, for simplicity, our XML file for the SVG might look like this. Importantly, we have this group tag that has the data that we're going to use to represent our coaster. You can see it has an image and the path that represents the circle that we're going to draw. Inside the app, here is what our 6 coasters would look like, and those would be 6 individual views. Those are individual, and we call them drag groups because we want the user to be able to interact with these groups independently. Now, why do we need this independent interaction? The material on the bed, as you can see there, might have holes or blank regions in it, and you want the user to be able to move these views onto an area on the material that is actually printable. For the layer or the path representing the circle, we can have a model that looks something like this. First, we have a layer, and the layer itself has a frame that can be used to position the layer within a view. And this is how we will find the frame of the layer or the circle inside of that coaster. We will use this dpath data, and we can use it to draw a Bezierpath. And once we have the Bezierpath, we can use the bounding rect property on CGPath to get a frame that we can use to draw our layer. For the image, the image would look something like this. It has a width, a height, an x and a y value for the origin, and it has this data tag that stores the data that you should use to draw your PNG. Importantly, it has this transform attribute that will help us to position our PNG in the middle of our circle or coaster. And the model for that would look something like this. Have the frame, the data, and a transform property. And then we get our drag group, that thing that the user can interact with independently. And that model would look something like this. It would have the layer for the circle and this image that represents the PNG file. And of course, for us to show this drag group, we're going to put it inside of a view that might look something like this. Transformations. So now that we have our layer model, we might want to add this layer to a view. That's how you would show that layer that you took from your SVG file. And adding it should be reasonably straightforward. You just find the layer on your view, and you add the layer from your path as a sublayer. But something unexpected happens. It's way off. Remember earlier when we tapped the inside portion of the eye of the cat, we outline the eyes snugly, which means the path were fitting nicely within that region, but it's not the case here. Why is that? So we had a layer frame, and when we were building the frame, we found the frame like this. We simply use the CGPath bounding box property on CGPath, and that would give us the frame of our path for positioning. But that position was for the layer inside the original SVG file. But remember, to show that group, we have a single view. So now we have to position that path within the view itself. So this is how we would fix that. We want to create a translation that will move the path back to the position that is going to fit snugly inside the eyes. So we multiply the origin point that we have by -1 to get the negative value of that point. And then we use that point to create a translation. And that translation now can be set as the transform on our layer. And this should fix our issue. Or will it? And it does. The path now fits snugly inside the eyes of the cat. Now let's move on to the image. Remember that the image had a frame, it had the data, and a transform property. And to show that image, we want to create an image view. And inside the initializer, you can see that we're setting the image by using the data that we got from our SVG file to create a UI image. And then we're setting the transform on this view to be the transform that was on the property, on the model. And once we have that view, now we can simply add it to our drag group view as a subview. And this should be reasonably straightforward. But now, the PNG file is positioned way outside the circle. Why could this be? This is how we set the transform property of the view. We set the transform by taking the transform of the model of the drag group image, and we set it, and that should work. But it doesn't. And here's why. In iOS, we do transformations around the center of a view. That is, if you were to take the diagram on your right, the unfilled box, and rotate it 15 degrees to your right, that's what you expect to get on iOS. However, inside an SVG file, when you rotate something 15 degrees, it rotates around the origin. That means it will take the entire file and rotate the coordinate system 15 degrees like this. And as you can see, the difference is dramatic. So how do we fix this? So remember I said that the rotation point on iOS is inside the center. And for an SVG file, it's at the origin or the top left. So first, we must move the point of rotation to the center. Then we can apply the transformation that we were given, but then we must move the point of the pivot point or the transformation point back to the origin. So what does that look like? I wrote this extension on CG Affine Transform that looks like this. It takes the point or the center of the view as a parameter. And we use that point, the center of the view, to create a translation. Once we have that translation, we can concatenate the transformation that we got from the SVG file. And once we get that, then we must concatenate the inverse of the translation that we created. And that will give us the transformation that we actually need for our view. And now our transformation inside of our view can look something like this. You simply call done around on transform, and that will return to you the right transformation. And now our coaster can look like this, what we expected, with the PNG file centered inside of the circle. At Glowforge, safety is very important. You're dealing with a laser, and you're cutting on material that can be incredibly valuable to you. For instance, I had a piece of material that I got from my grandfather, and you don't get to destroy that twice. For most of us, if you have a bug in your app, you can tell the user to quit the app and restart. Maybe it will fix it. But you can't tell the user to quit the app and get their material back. So I spend a lot of time thinking about how I could write my code so it's safe. And one way I do that is I use value types to model majority of my data. And that way, I get rid of a lot of unwanted or unexpected mutation. I also use abstraction, maybe to a fault. I want to be able to reason about different portions of my code independently. And once I do that, I can also get to test those portions independently. As you might have seen from my slides, all the transformations occur independently. The transformation on the path was independent. The transformation on the image was independent. The transformation on the view was independent. For me, untested code is incomplete code. It doesn't mean you can't ship incomplete code. But for me, testing is very important because we don't want our users to destroy their material that might be valuable to them. So I write a lot of tests. And things are tested independently and then tested as an integration. So writing code for the Glowforge it's very fun. It's pretty exciting. When I'm testing my code, I could just make something that I wanted to make for a while, like a wallet, just to test my build. And it is fun, but I'm also the only engineer there, and it can be very stressful at times. I can't tell you how much material I destroyed trying to get this to work. Multiple times, I would send a print to the printer, and it would print the image over here and the path over here, and I have no clue why it's doing that. And I go to Google and I type, why would the image be outside of the path? And Google is like, no results. Because most people aren't experiencing this. Most people aren't working with an SVG file inside of an iOS app where they have to do these things. Hopefully I showed you that today. Thank you.